subject, we need to study about the main topic, that is electrostatics. We'll study now. So what is this electrostatics? Electrostatic is, it is a field that is produced due to charges at rest. Whenever the charges are stationary, whatever the field or the effect that is produced due to these charges, we call it as electrostatic field. So in this, based on, listen here, based on these static charges, we are going to define a law called, that is Coulomb's law. So in this also, in the objective type, they may ask you some definition and you should be able to explain the definition here. That is, put a tick mark for the respective definition. Definition should be clear, or they may ask you some formulas for the MCQs type, objective types, and for the subjective, you may need to derive some small equations, or you need to do some problematic. So everything will be involved for the term test 2. All types of problems will be there. So please listen properly, and the statements or derivation or formulas, whatever it is, anything can be asked. So please concentrate and listen. And after revising this, please once again all of you revise. So let us define Coulomb's law. So in order to define Coulomb's law, you take 2 point charges. First, we define what are the different types of charges we have. We have mainly 4 types of charges. One is point charge, line charge, surface charge, and volume charge. In this, we are considering a point charge. Point charge is a charge whose length is very negligible, or it is too small, the length will be. So such kind of charges we call it as point charge. So here we are considering 2 charges, Q1C and Q2C, which are separated by a distance of r meters. Whenever we place a charge like this, there is a force of attraction or repulsion between the charges. So force of attraction will be when both the charges are having different polarities, there is a force of attraction. When both the charges are having the same polarities, there will be a repulsion between the charges. So it can be either force of attraction or force of repulsion exists between the charges. So whenever we place a charge like this, whatever the force that is developed is proportional to product of the charges, that is Q1 and Q2, first thing, and it is inversely proportional to square of the distance between the charges, that is F is proportional to 1 by r square. So if you combine these two statements, F is proportional to Q1 Q2 by r square it will be. So if you remove this proportionality by some constant k, so F is equal to k Q1 Q2 by r square. So what is this k? K is nothing but constant of proportionality, and it is equal to 1 by 4 pi epsilon. So what we as Coulomb's law define? The force is proportional to product Q1 Q2, F is proportional to 1 by r square, and if you combine those two, F is proportional to Q1 Q2 by r square. The proportionality is removed and we are going to replace it by k, where k is called constant of proportionality, that is equal to 1 by 4 pi epsilon. What is this epsilon? Epsilon is a dielectric constant that is equal to epsilon naught into epsilon r. Epsilon naught is absolute permittivity, which is a constant value 8.854 into 10 raised to minus 12. Epsilon r is relative permittivity, which depends on the medium. So in this, k is equal to 1 by 4 pi epsilon. Epsilon is epsilon naught into epsilon r. Epsilon naught is absolute permittivity. Epsilon r is relative permittivity that depends on the medium. So finally, we can write F is equal to Q1 Q2 by 4 pi epsilon r square. So this is called Coulomb's law, that is force equation in magnitude form, that is described using Coulomb's law. So in this we have what? F is there, that is force is measured, all of you know, it is in Newton. Charge is measured in coulombs, and R is nothing but distance. We are going to measure it in meters, not centimeter or millimeter. R is measured in meters here. So F is equal to Q1 Q2 by 4 pi epsilon R square is the expression for the force that is produced due to what? 2-point charges by using Coulomb's law. Next thing is, since force is a vector quantity, we need to express all the vectors in the vector form itself. Now we have represented in the scalar form here. Now we need to represent that force in the vector form. So how do we represent here? See, all of you should know, in order to represent any parameters in the vector form with respect to distance, if you take, you need to have the position vectors. So what is this position vector? It is the vectors that is measured from reference point or from origin, you can tell. For example, in this figure, now we need to represent force, whatever I have derived, that should be represented in the vector form. In order to do that, we consider a origin O and Q1, Q2, two charges which is placed at P1 and P2. From origin to Q1, the position vector is assumed as R1. From origin to Q2, the position vector is assumed as R2. And the distance from P1 to P2 is R12. P2 to P1 is taken as R21. So we have 4 different vectors, R1, R2, R12, and R21, which is represented in the figure. Now, whenever we place a charge like this, in vector form, if you take, two forces will be acting one on the other. For example, first one is what? We can take the vector force that is produced due to Q2 on Q1. That is, it is moving in the direction 2 to 1. So whenever you write it is in which direction is moving, based on that you can write F21. So what is F21? It is the vector force that is exhibited by charge Q2 on Q1. So F21 is Q1, Q2, 4 pi epsilon R square. Magnitude part will be same, and the unit vector will be what? AR21, because you're calculating in the direction 2 to 1. So F21 is Q1 Q2 by 4 pi epsilon R square into AR21. So how do you define AR21? I told you unit vector is defined as the vector divided by magnitude of the vector. So I want to define the unit vector for R21. So it is the R21 vector divided by magnitude of R21. So F21 you have written it as what? Q1 Q2 by 4 pi epsilon R square. AR21 is there. AR21 is a unit vector. So it is defined as R21 by magnitude of R1. And all of you should know R is the distance between the two charges. So R, magnitude of R12 or R21 will always be equal. So in the above equation, R can be replaced by R21. So before that, what is written? R21, how do you write? It is R1 minus R2. You write R21 as R1 minus R2. Then small r is equal to magnitude of R21. So it will become magnitude of R21 the whole cube. So in this equation 1, what you're defining finally, the vector force that is exhibited by charge Q2 on Q1. Understood? F21 is Q1 Q2 by 4 pi epsilon R square AR21. AR21 is R21 by magnitude of R21. And R21, how do you write? It is R1 minus R2, that is final vector minus initial vector. R and magnitudes are same, so it will be equal to Q. So equation 1 will give you the F21, that is force due to 2 on 1. Same thing you can write the other one, that is what? Force due to 1 on 2, you will arrive with equation 2. same procedure you can apply here, you'll get equation. 1 and 2, if you compare, what you conclude? Magnitude part is same, denominator is same, only the numerator part R1 minus R2 will change to R2 minus R1. So by comparing equations 1 and 2, we can write F12 is always equal to negative of F21. Or magnitude wise, if you take magnitude of F12 is equal to magnitude of F21. So this is about the Coulomb's law in vector form. What are the possible MCQ you can ask here in the vector form if you take? So how do you express F21? Equations they may ask. And what is R21? R21 is R1 minus R2. And what is the relation between F12 and F21? Both are negative, or it is positive, or it is not equal, anything like that they may ask. And if you take magnitude wise, whether they are equal or unequal, or it is twice, anything like that, possible questions may be asked on this Coulomb's law. That will in vector form and magnitude form. Anything will be asked, you keep in mind properly. Next, coming to the basic problems on this Coulomb's law, it's very simple. Just whatever you have derived now, you need to apply that and calculate the numerical value for that. So you keep in mind that ends is very important here. After reading the problems, some ends I'll give. Those ends you have to keep in mind so that you can solve the problem in a 3 or 4 step instead of writing each and everything here. Understood? In minimum time, you should be able to solve the problems. The first problem is they have given two charges. One is positive charge and another one is negative charge that is located at some points they have given. So what you need to find is what is the vector force on the positive charge and what is the vector force on the negative charge we need to find. And what is the magnitude also you can find here. So we need to find what? Two charges and the respective points are given. We need to find the force on the positive charge, force on the negative charge. So first and foremost in the problem is, if they have given points and the corresponding charge, you can draw a rough figure and you can calculate directly. For example, in this first charge, you can take it as Q1. The corresponding point is taken as P1. Second charge is Q2. The corresponding point is P2. So draw a rough figure based on the data which is shown here. Now what is asked? Vector force on the positive charge. So vector force on positive means it is understood it is due to negative charge. So you need to calculate F21 for this. You write whatever formulas you have arrived, and another important thing is epsilon r is not given in the problem. So if epsilon r is not given, whenever we write epsilon will be equal to epsilon naught only. If epsilon r is given, then epsilon should be replaced by epsilon naught into epsilon r. Understood? So F21 in this case will be Q1 Q2 by 4 pi epsilon naught R21 by R21 the whole cube. Then you substitute Q1 is 3 micro, Q2 is minus 5 micro, and 1 by 4 pi epsilon naught is how much? 9 into 10 power 9. That is a constant value all of you should know. Then R21 is what? R1 minus R2. You should know that. So how to find this R1 minus R2? That is, you need to subtract P1 minus P2. The points P1 minus P2, if you subtract, what you get? 0 minus 1 to AX. That is minus 1 AX. 2 minus 2 is 0, 0 AY. 3 minus 4 is minus 1 AZ. So R1 minus R2, if you want to calculate, you need to subtract P1 minus P2, not P2 minus P1. R21 is R1 minus R2. That is, you need to subtract P1 minus P2. How do you subtract? 0 minus 1 into AX plus 2 minus 2 into AY plus 3 minus 4 into AZ. And once after calculating magnitude will be what? Square root of the coefficient whole square, and then you calculate its cube. And another important thing is you should not multiply the magnitude part, the powers. The powers you need to simplify first. That is minus 6 is how much? Minus 12. Minus 12 plus 9, if you add, it will be minus 3. So keep those power simplification as it is. Don't multiply 10 raised to minus 3 into 135 and write the value. So those minus powers till the end you can keep as it is, and finally you can write it in either milli, kilo or mega, whatever it is based on the power. So first and foremost, while doing the magnitude part, powers should be added or subtracted, and you have to keep those power values as it is. For rest of the thing, you need to simplify it. Understood? And at last, what you should do, that 10 raised to minus 3 should be written as millinewton. So this is the simplification part I'm telling. You should do it in a simpler way. And finally, that milli you should write as it is. So what is this done? First one, vector force on positive charge due to negative charge we have calculated, that is F21. And next second one they have asked vector force on negative charge, that is F12. F12 is always equal to negative of F21. Whatever value you got for F21, if you multiply it by minus, you'll get the value for F12. No need to do the calculation part again. Whatever the above force you have calculated correctly, multiply that with just minus, you'll get the value for F1. So this is problem on Coulomb's law. So what does it state, or what is given here? Two charges, 2 points. You need to find F21 by applying the formula. Then F12 is minus of F21. If you multiply by minus, you'll get the value. Same thing, second problem is also asked. So they have given two charges, 2 points. You calculate whatever force they have asked. Next is listen here for the third problem. We have two charges here, 3 nano and 2 nano coulombs. Both are separated by 6 meters apart. And this is placed in a dielectric medium, epsilon r is equal to 5. So they have given a dielectric constant of epsilon r is equal to 5. So two charges are there. They are separated by 6 meters apart, and this is placed in a dielectric medium having relative permittivity epsilon r is equal to 5. What you need to calculate here, we need to calculate the force between the charges in the first case. Second case, if the charges are brought in contact and then separated, what is the force between them you need to calculate. So in the two cases they have given, in both the cases you need to find what is the force between the charges. So one thing is, compared to the previous problem and this problem, previous problems they had given points. In this problem, the point is not given. So what you need to do, you need to mark the charges or take the charges along the coordinate axis. How to take? The first charge should always be kept at origin. So you'll get the coordinate P1 as 0, 0, 0. What is the distance mentioned? 6 meters. So it is a positive value. So you can take it on y-axis. So P2 will become what? 0, 6, 0. So like this, placing one charge at origin and another charge on positive y-axis, you can get the 2 points P1 and P2. Once you get the points and once you know the charge, you can calculate whatever force you have. They have asked what force between the charges means. Either you can find F12 or F21, but you need to calculate the magnitude part of that. So, and another thing is epsilon r is given. So write epsilon naught into epsilon r and calculate here. Second case is if the charges are brought in contact and then separated. What you should do in this case, if the charges are brought in contact means both the charges you should add. Q1 plus Q2, if you add, it will be 5 nanocoulomb. And then if they are separated means it will divide equally. So Q1, Q2 will be equal to 5 by 2, that is 2.5 nanocoulomb. Once again, after bringing contact and separating, repeat the same problem again and calculate the force between the charges and magnitude of the force. Understood? So these are the three basic problems you need to do it on Coulomb's law. So in the MCQ, you may ask these problems. You need to calculate and find the value. For example, they will ask you what is F21 value. Some numericals will be given. You need to put a tick mark for F21 or F12 they may ask. Or they may give equations. You need to identify what equation it is. And another thing, they may give the diagram also. Is this diagram is relevant for the given statement? Which diagram is relevant for the above statement? You should be able to identify the diagrams also. Understood? So they may ask you the solution they may give and ask the statement whether which statement is relevant to this figure or statement they give and which figure is relevant for the above statement they may ask, or they may give you the answer. Is it which answer is correct? You need to identify. Understood? So another thing is whenever the points are not specified, you need to take the charges, first charge at origin, second on any of the positive or negative depending on the value, and you should find what P1 and P2. Then you can proceed as similar one. So this is about the basic problems of Coulomb's law by considering 2-point charges. I think all of you have understood, and while doing calculations, you should be able to do fast. Simplifications are very important. Next thing is force due to multiple charges. The concept is same. Instead of 2, I am taking multiple here. So what is here? Q1 to Qn. N number of charges are there. They are located at points P1 to Pn. Due to all these n number of charges, we need to find the force at the point P, which is carrying the charge of Q coulombs. So here we need to find force due to multiple charges. What is considered? Q1 to Qn, n number of charges are there, which are located at points P1 to Pn. Due to all these charges, we need to find the vector force at point P having the charge of Q coulombs. So what is the force here? We are calculating the resultant force at point P. So we are calculating the vector force at point P due to what? In the direction first P1 to P, P2 to P, P3 to P, and Pn to P. So what is the resultant equation? Fp1 to P, Fp2 to P, third is Fp3 to P, and last one is Fpn to P. So we have n number of individual forces acting at some points on the charge Q coulomb. So Fp is given in this form. So for each of the force, you write the Coulomb's law, whatever you have derived before. That is Fp1 P is what is the Coulomb's law for that? Q1 Q by 4 pi epsilon. The vector will be Rp1 P by magnitude of Rp1 P whole cube. Same thing you can write for Fp2 P and so on up to Fpn P. Fp2 to P. All these n number of forces, you can remove common. Q by 4 pi epsilon is common, and you can write the resultant equation. So this Fp is the resultant force that is produced due to n number of point charges Q1 to Qn on the charge Q coulombs. So what you should write in all the problems or in the derivation part. Now based on this, we'll solve some simple problems here. So it is similar. We have done previously F1 to or F21. Now you need to calculate n number of forces or 3 or 4 forces here. What is asked in this? We are having 4 like charges. That means all the values are same. Q1 to Q4 we take. 4 like charges are located on x and z axis at a distance of plus or minus 4 meters. So we have having 4 like charges of 6 microcoulomb each located at a distance of plus or minus 4 on x and z axis. Due to all these charges, we need to find the resultant force on 3 microcoulomb, which is located at the point 030. So this is the statement given. For this statement, one thing what you should notice, distance is given, not the points. That is plus or minus 4 meters is given. For that, they have not given the points. So what you should do, while calculating the solution, you need to draw the figure on the coordinate axis x, y and z. So first charge is located on x-axis at 4 meters. So let us take the point P1 as 400. The corresponding charge is taken as Q1, which is equal to 6 microcoulomb. And P2 will take negative x-axis, that is minus 400, and the charge is same at that point, that is Q2 is 6 microcoulomb. And where is the third charge? On positive Z. So it will become P3, that is 004. Charge is same Q3, that is 6 microcoulomb. And P4 is negative Z 00 minus 4, that is Q4 is 6 microcoulomb. Like this, at a distance of 4 meters on plus x, plus Z and minus Z, you place 4 point charges Q1 to Q4. Due to all these charges, where we have to find the resultant at 3 microcoulomb, that you can take it as Q is equal to 3 microcoulomb, and the corresponding point is taken as P for this, that is 030, which is on positive y-axis. So now where you're calculating the resultant? On y-axis at the point P. So it is FP you're calculating. In what direction you're calculating? P1 to P, P2 to P, P3 to P, and P4 to P. So write F in first form like this. Then what you're for each F1, FP1, P2, FP4, P, write the Coulomb's law first. Whatever charges you have taken, write that Q1, Q or Q2, Q, write it. And another thing is what? Epsilon naught you should write here. It's not specified, you should write epsilon naught because epsilon R is not given. And after writing all this, what is common you should see here. What is common? See, Q1 to Q4 is common. That is all are equal to 6 micro and Q is 3 micro. So product of the charges are same and denominator 4 pi epsilon naught is same. So you can remove the magnitude part, whichever is common, you can remove it outside and then you can calculate the values inside the bracket here. And then I told you how to simplify. Always while simplifying multiple forces, you need to remove common, simplify the powers, and then the bracket values you need to simplify. Then you have to multiply the bracket value with the outside value. And till the end, that powers, whatever is there, 10 raised to minus 3 or whatever, that should be retained till the end. And you should write finally as milli, kilo or whatever you get, you should represent it. Understood? So the simple thing what you have to follow here is read the statement, draw the figure for that properly, and where you're calculating the resultant force, write first the equation in F form, then you apply Coulomb's law for each of the individual forces. Whichever is common, you try to remove it, then you can simplify it easily. So this is the 4 like charges are placed on x and z axis. We need to find the resultant at some point. The same thing can be applied for square also. So in this, what they've given? They have given 4 charges are placed at 4 corners of a square. All are equal to 3 microcoulomb. and the side of the square they're specifying it as 4 meters. Due to all these force charges at any one corner, you need to find the coordinate. So first here for the solution part, all of you remember, if you have a problem related to the square, you place a square in such a way that all the corners come in any one of the axes like this. See, A, B, C, D are the 4 corners. All the corners are placed on the respective axis like this. So what is the advantage here is, if you place the corners like this, it is easy to find the coordinate. And then they've given the sides is 4, and you can get the adjacent sides or the opposite sides. What type of triangle will form here? Isosceles triangle. You'll get isosceles triangle. So you can, using Pythagoras theorem, you can find the distance. So all of you should have in mind, whenever they give a square or an equilateral triangle problem, the corner should be placed on any one of the axes, so that it will be easy for you to calculate the side distance and write the coordinates. Once you write the coordinates, you can find the force on any one of the corners where we have found here. So let us find the force at corner A. So FA it is. In what direction you are calculating? D to A, C to A, and B to A. The remaining calculation will be same as the previous one. Only thing, you need to read the problem, write the figure for that, and write F properly first. Understood? So what is this problem states? We have 4 light charges located at 4 corners of a square having a side of 4 meters. We need to calculate the resultant force at any one of the corner due to remaining charges. So we have remaining charges means 3. So 3 forces will be acting at point A on point A. So calculate for that. Same problem can be applied for equilateral triangle also. Same thing. Instead of square, you change it to triangle, and you can place a triangle like this, which is shown here, so that all the corners come on any one of the axes. And while calculating the distance to write the coordinates, it is easy for you. What will happen to this AC side? Half part of the AC is on which axis? Negative y, and half part is on positive y. So positive y will become plus 2, negative y will be minus 2. And how do you find this height on z axis? Pythagoras theorem, if you apply, you get this height. You can write the coordinates. Once you write coordinates, you find force on any one of the corner and calculate it. So till here, all of you should revise properly, and the last 2 problems are assignments. Homework is, if you want, you can solve, or you